Earlier this week, we've already seen that the dot product plays an instrumental role in matrix-matrix multiplication. We saw that in order to compute an element of C, you take the dot product of a row with a column. Let's look at the dot product a little bit more carefully in isolation. So we have a vector x and a vector y. Notice that we use Roman lowercase letter x and lowercase letter y to denote these. Its elements can be exposed as chi0, chi1 through chi n minus 1 if the vector is of size n. And similarly, the elements of y can be exposed as psi0, psi1 through psi n minus 1, where psi is the Greek letter psi, the lowercase Greek letter psi. Okay, so we typically write taking the dot product of vector x and y as x transpose times y. Now why is that? Well, notice that we can also think of this vector x as being an n by 1 matrix and this vector y as being an n by 1 matrix. Let's just plug that into this formula. X then would be written as chi0, chi1 through chi n minus 1 transpose times psi0, psi1 through psi n minus 1. Now, what happens when you take a matrix and you transpose it? The column vector then becomes a row vector. Chi0, chi1 through chi n minus 1 times psi0, psi1 through psi n minus 1. Okay, so now we're doing a matrix-matrix multiplication of a 1 by n matrix times an n by 1 matrix. And how does that work? Well, the entry is computed as this times that plus this times that, etc. So that becomes chi0 times psi0 plus chi1 times psi1 all the way through chi n minus 1 times psi n minus 1. Now, it gets a little tedious to always write this dot dot dot, and therefore this is often simply written as the summation over I equals 0 to n minus 1 of chi sub I times psi sub I. So here we've revisited a whole bunch of things we've seen already. Lowercase letters for vectors, lowercase Greek letters for the elements. A vector can be viewed as a matrix. We understand now why we put a transpose on it in order to take a column vector into a row vector. And we've now linked that to why we compute a dot product the way we do. And we've introduced the summation notation along the way.